Okay, moving on to part 3. So we've already determined that we're not getting any thermal response from this when it's powered on. You probably can't make that out, but I have the datasheet for this chip. It's the general datasheet for the LM3S 1D21. There's a lot of sub like chip denominations after that, but this is the pinout for this package. So it gives me the points at which voltage feeds in, and that'll let me test and see, hey, is it receiving power? That would be the first step. Another way to go about this is just to look for test points. It was suggested to me to look for test points for the 5 and 12 volt rails, but I'm just going to start out probing the pins specifically to see if the chip is receiving voltage. So we have the 65A there. Got my probe masters. I might need something finer tip than this. We'll see. And we will need to power it up. So, the reference I'm looking at has the orientation dot at the top left, and I'm seeing the chip oriented with the orientation dot at the bottom right. So I'll need to invert what I'm looking at versus where I probe. Okay. So going from this way forward, or yeah, 1, 2, 3, 4, 5, red on 6, ground on 7 is where I need to be. This way, red on 6, ground on 7. And be careful not to bridge anything. So 1, 2, 3, 4, 5. Okay, I had 3.3 volts, so that's one of the inputs. I wonder if I have something finer tip here. I believe I do. Probes? Got these from Mechanic. These are excellent general purpose, but for SMD, yeah, I'm going to want the really fine needle point here. I'm worried about bridging contacts on the 3.3 volt rail, or a 3.3 volt pin. So let's hang these up. And I'm not worried about the difference of a few milliohms between the Mechanic probes and the probe masters. It's not a problem. But there are 4 sides that have power going in. We have a couple different style tips here. I'm going to take a look at these under the microscope and see what's more fine. I guess the non-tapered will do. So that's the shorter one? Yeah. Or the one that doesn't have two tapers. I like having options for, if not the exact right tool for the job, then as close as possible. Sorry, muttering to myself. Okay, so red on 6, black on 7. Can I get a little closer here? Yes, and I want as steady as possible. 1, 2, 3, 4, 5, 6. .3. Okay. So yeah, that was just retaking that same reading. Yeah, still no heat, no feeling of warm on the chip. Next side over. Red on 3, black on 4. Okay. Want the wrists resting on things. Very carefully. .3 volts. I swear it really doesn't come across how nerve-wracking it is to be probing the voltage pins on the MCU of like an instrument that costs like $5,000 and be worried about bridging voltage onto the next pin over that should not be exposed to that. Like, don't destroy a $5,000 instrument. Don't destroy a $5,000 instrument. Not used to that kind of pressure. All right. Opposite side of the dot. Starting from down straight from the dot. 1, 2, 3, 4. Let's use the mouse. 1, 2, 3, 4, 5, 6. Pin 7 is red. Pin 8 is black. Okay. Wrists on the sides. Careful not to push the power cord in over much. So we're at 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8. 7 is red. All right. 1, 2, 3, 4, 5, 6, 7. .3 volts. I just realized it would be really great to somehow have my multimeter display in the eyepiece of the microscope. Huh. Or I guess... Oh. Alright, it's not as good as direct optics, but... can turn on the microscope camera, I guess. I have a good camera. Camera is never as good as direct optics. Nothing will ever be as good on a microscope as direct optics. You're gonna give me a video out there. Wake up. I guess I should check what pins do I need. There are actually multiple power rails per side. I've checked one so far. I'll go back and check more. One, two. All right, so starting from the dot side, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7 is black, 8 is red, going this way. The 7 is black, 8 is red. Hey, microscope, you gonna give me video? Yeah, okay. Okay. Yeah, perception of depth is not nearly as good as the optics. Let's bring this over a little bit. One, 2, 3, 4, 5, 6, 7. And there's 3.3 volts there. I mean, that's not every voltage input, but that is one on each side. Oh, hey, that's convenient. If we look right there, is that little resistor or capacitor or whatever it is, the SMD? 1, 2, 3, 4, 5, 6, 7. Oh, that's such a better test point. I'm gonna guess that that's a capacitor, probably to act as both. I mean, here's a nice little test point for you to check voltage, to not have to do what I was doing before, and probably for smoothing any little bit of noise that the capacitor can smooth out. In that case, let's check all of the capacitors that are right next to each other. Yep, that's a voltage rail. Well, that's convenient. How about you? Negative 3.3. Oh, that's so much nicer. How about you? 3.3. 3.3. Careful. 1.3. 3.3. 3.3. Guess we can just check across all these little capacitors. Three point three, 1.3, 1 volt, 2.3, half. So yeah, it's we can go ahead and double check thermal. Now, just because it's getting voltage does not mean that's all that's required for it to turn on. Yeah. I have the camera centered on the MCU. There's no thermal response at all. Like you can see the outline of it, and there's no heat. So it might need... There might be some kind of clock signal that's supposed to go into it, or other factors to tell it to turn on that I'm not aware of, but it looks like it's getting its 3.3 volts on all of the connections that I can see to check. So yeah, it's possible that the MCU is dead. All right, well, that was the next stage of verification. We know it's getting voltage. I'm going to call it here and upload this so other people can look at it and go back to the forums to consult. See you again.